Hi YouTubers, Dave out in Western Pennsylvania, USA. Here's a small commercial sealed gel lead battery, 6 volts, and I think they have on there, it was let's see, something like 1200 milliamps divided by 20 hours. 20 hours is used with lead batteries. It's a small 6 volt, and I popped the top, removed the sulfuric acid with aqueous bicarbonate and distilled water rinses, and charged it with Rochelle Salt. And Rochelle's is sodium potassium tartrate. It's a venerable chemical commodity used in many applications, piezoelectric. I have a 20% mass volume solution. I just charged this up for this YouTube video, 8.5 volts, and I think I gave it about 0.8 amps, 15-20 minutes to charge it up. You can see the open voltage right now is 6.34 volts. I'm going to run this demo at 2 amps. Cutoff voltage 2 volts, and I'm using the ZKE Tech battery tester electronic load. Now I have model here EBD A20H. It does not do the 5 cycles. The model A10H does. I'm getting 2 of those in. These are very, very affordable, and it's a very good functional unit. So we're ready to go, and let's see what will occur with the performance. So we'll start. Fan just came on. Started at about 12 watts. Of course, that's going to drop. I've been up to a discharge of 7 amps, and taking it down to 2 volts, normally that would kill a wet battery, conventional lead acid. It would kill it very quickly. I've done 7 cycles at various amperage discharges, constant current, and I always go down to 2 volts. I haven't gone lower than that, but it's a significant depth of discharge. And you can see it's running for just under a minute. And the open voltage when I began was 6.32. It's at 5.67 volts right now. The capacity is right to now 39 milliamp hours. Is up to 41. The energy is 242 milliwatt hours. And this is just to let you see the performance of this small lead battery with Rochelle's Salt. And the profile is such. Right now it's moving along pretty good, but then it will start to slope down, and you'll get a warning once the current voltage lines cross. It will angle down and pretty much drop in potential. Also, I want to show you the rebound voltage, and that's always a good sign with a battery when work is done, to see how it rebounds. So we're running for over 2 minutes right now, and notice the voltage, the potential just dropped below the current, which is constant. I paid for this particular electronic load battery tester. I got this one on Amazon for $125 or so post-paid in the United States. And I have the 2 model A10 coming in. They're about $125 each. Very, very good unit. Reliable. I think it's 16 gauge wire for the current lines. You're still at 5.41 and 10.76 watt output right now, but of course that will change as the voltage drops. Cell capacity right now 107 milliamp hours. The energy is 605 milliwatt hours, and definitely the cell is getting stronger with each cycle of charge-discharge. Clearly, it is getting stronger. And of course, Rochelle Salt is easy to prepare and rather inexpensive and very soluble in water. And I have it at 20%. I'm going to go up to 30% and see the effect. We don't want to have too much resistance. And this is one of the projects I work on. I'm also working with iron battery, but I'm going to be using a graphene electrode with significant surface area. But that's for another video. We're still at 5.12 volts. That's pretty good. But then again, we're drawing 2 amps out of it. And I have some data for you to look at from an earlier run. This, I just want you to see the graph and the performance, the profile of it. It charges up very quickly. So of course this is not a aqueous sulfuric acid 33% lead battery. The lead batteries are about 54% of the global market, and they're not going anywhere in the near future. Now, do you see the voltage starting to angle? Now we're down to 4.89 volts, and you can see it's angling down, and then it will begin, it's more gradual, but then it will sharply decrease. But I think this is an electrolyte worth investigating. Make sure you remove all of the sulfuric acid from the gel electrolyte and wash it thoroughly with aqueous bicarbonate a number of times, and then distilled water, and then charge with the, as I said, very soluble Rochelle Salt. This has been running now for coming up on 6 minutes. We're at 194 milliamp hours and 1040 milliwatt hours. It's angling down. And I would imagine we'll get another 3, 4, 5 minutes. I've been up to 7, I think, 7 amperage I've drawn. But you're seeing the angle, the graph, the slope, down to 3.92, and that will begin to drop. In any event, worth investigating. Here's the unit again. ZKE Tech. Model EBD A20H. But A10H will give you 5 cycles of charge-discharge with optional rest periods. I'll be getting in, as I said, 2 more units for my students here at school. And always good to work with the lead batteries. It's a good place for students to start with. 3.18 volts, 248 milliamp hours, 1246 milliwatt hours. We're going into that decline now. We'll be coming up on 8 minutes. 2.5 volts. It's going to sharply drop. 2.29. We're going to want to see the rebound voltage when we shut off. 2.06 volts. We're going to get about 8.5 minutes and the machine has shut off. So I'll remove that stop. Fan just went off. And you can see it's starting to rebound. Usually it goes up to 5.45, 5.5 volts, but that's a sign of battery strength, that it's attempting to rebound. And I've seen no damage to this battery with this use of Rochelle's Salt. Yep, there it's going towards 5.5 volts. I usually give it 2 or 3 minutes at 20 degrees Celsius to rebound, and then with that. So our specs: 279 milliamp hours, 1324 milliwatt hours. The open voltage was 6.32. I'm not going to give you a nominal voltage because of the nature of this discharge pattern, but hopefully that will give you an idea of the research I'm doing and what you can do with this electronic load device. Thanks for watching. Bye for now.